students, welcome to this video. In this video, I will discuss about 10th lesson electricity. This video help you conceptual understanding with proper images and certain formulas help you to solve some suitable problems. Good morning. Today, let us discuss a new lesson electricity. In a nature, the electricity is conducted only in the presence of electric charges. There are two types of the electric charges. Let us see a picture here. One is a positive charge and one more is a negative charge. In a nature, these two positive charge and negative charges are always equal in any object. This electric charge can be denoted by a letter Q. The unit SI unit to use the measure the electric charge, that is Coulomb. What do you mean by Coulomb? You see this figure. It is a part of the conductor which is used in a electric circuit. Here you see this is the area of cross section of a conductor. The number of the electric charges that is passes through from this area of cross section of a conductor in a second, that is called as a coulomb. That is, 1 coulomb is nothing but, you see, this is the area of cross section of a conductor. From this area of cross section of a conductor, 6.24 into 10 to the power of 18 number of the electric charges are passing through this area of cross section of a conductor. That is nothing but 1 coulomb equals 6.24 into 10 to the power of 18 electron or the protons which are passes through in 1 second in a area of cross section of a given conductor. Let us discuss about electric circuit. You see a picture here. You see this is the battery. On one end the terminal, this is the positive terminal, and one more end, that is a negative terminal. Now the positive terminal is connected by the conductor to a bulb, and then other end of the bulb is again connected by a conductor to a negative terminal of a battery. Now what happens when the switch is on? The bulb is glowing. This is called an electric circuit. Now this can also be written in a sketch diagram. You see, this is the battery. Now this battery or a shell can be right in this form. You see, one a long line, short line, long line, short line, long line, short line. The long lines are represent a positive terminal and the other end, the short line, represent a negative terminal. Now the conductors from a positive of the battery to the negative of the battery is connected. That is called one electric circuit. You see, the positive terminal of the battery is connected to the bulb. Bulb is connected to a switch and the other end of the switch is connected to a negative terminal of the battery. This is nothing but a closed path of a flowing current. Now, you see, a continuous and closed path of an electric current is called electric circuit. Now, let us discuss about the new terms one by one. One is electric current, and then we discuss about potential difference, and then again discuss about resistance of a conductors. Now let us discuss one by one. Electric current. All of you look here, a picture. You see, this is the battery positive terminal which is connected to a one electrical device, and then the other end B is connected to a negative terminal of a battery. The charges are flows from positive terminal. You see, we are showing a arrow mark like this. These charges are moves from a end of a electrical device to a B end, and from the B end they are reached at a negative terminal. This is a circuit. And now, what do you mean by electric current? You see, the flow of charged particles moving through an conductor in a unit time. The charges are moves from positive terminal to negative terminal. They are move in this conductor in unit time, means 1 in 1 second. This can also be defined as the net rate of flow of electric charges through a surface. From this surface, in 1 second, the number of the charged particles are flows from a surface A. For the convenience, we can be also written as current, that is equal to number of charged particles divided by time. You see, the charged particles, electric charges can be denoted by Q, time can be denoted by T, and the current can be denoted by I. This can be written in the symbol form. You see, I equals Q by T. SI unit of electric current is ampere. The symbol of the ampere can be written as capital letter A. Now, what do you mean by ampere? Ampere is when 1 coulomb of electric charges flows through the area of cross section in 1 second. Ampere nothing but in a area of cross section within a 1 second, the 1 coulomb charge is flows through it. Now, this can be said to be 1 ampere. We know this already, this formula, current is equal to electric charge by time. In SI unit, current can be represented by ampere. 1 ampere, that is equal to the electric charges can be represented by coulombs, that is 1 coulomb, divided by time can be represented by seconds, that is 1 seconds. Again, the ampere can be also expressed as coulomb per second. Now, let us discuss about the potential difference. You see a picture here. This is a battery or voltage source. In this battery, the positive terminal is connected to a device at one end, that is here plus is there, and one more, the other end is connected to a negative terminal of the battery to a device, that end is minus. This plus symbol nothing but it is the higher potential, that means a higher energy level, and one more here the negative end, that is the lower potential, nothing but a lower energy level. If a charged particle can bring from one point to another point, certain amount of a work will be done. That work will be done due to a charged particle can move from one point to another point, that is called as potential difference. That potential difference can be denoted by capital letter V. The potential difference can also be expressed in the form of V equals amount of work done divided by charged particles. Now, this can be right in the symbol also. V equals work done can be written as W and charged particles can be symbolized by Q. SI unit of potential difference is volts. Volts can be denoted by capital letter V. Similarly, SI unit of work done is joules. Joules can be denoted by J. Thank you for watching this video. In my next video, you will study relation between current and potential energy by George Ohm and resistor, and then the heating effect by James Prescott Joule. Thank you.